Okay, so if x1 is this and x2 is this, then the linear combination of x1 and x2, which is a multiple of x1 added to a multiple of x2, right, has this form, c1x1 plus c2x2, a sum of multiples of the x1 and x2 vectors. And you can visualize that by a couple of vectors in two-dimensional space. Now the problem in the book has three-dimensional vectors. Well, that's a little harder to visualize. Okay, but you can. It's our familiar three-dimensional space. So I'm just doing it in 2 dimensions, but in 3 dimensions, you just got another number to write down. Okay? So you have this, and you want this sum of multiples to equal this vector. Remember, we did that with pictures. You know, with here's the vector, here's the vector. Now we want to get this one, so we go out so far along this one till we're in a position where we go in the direction of the other one to get this one and all that stuff. So this equation becomes well, I'll write it out. Comes this, and we could write this now as a system of equations. 3c1 minus 5c2 equals 9, right? 7c1 plus 2c2 equals negative 2. Well, the other way to write this, and this is a little twist, but it's a very important twist, so we want to be sure we have it. And again, we've done it, but not recently. This can be written then as matrix equation. Now, when we did it originally, we went ahead and wrote out the 2 equations you get here. Okay? And then we interpreted those 2 equations as a matrix equation. Well, the matrix equation is just this. And you want to be sure that you understand why. Okay? And why is it? It's because your matrix equation is 3c1 minus 5c2 equals, not your matrix equation, your system of equations is this, right? And this system can be written. This is how you write the system as a matrix equation. Okay? So C1, C2 is the inverse of this matrix multiplied by the 9, negative 2 vector. If the matrix is non-singular. What do we mean by non-singular? It means it's invertible. It means if you write it down with the identity matrix, you can reduce it to the identity, so you get an inverse. If it doesn't reduce to the identity, it's not invertible, and you can't do this. If it doesn't reduce to the identity, you get 2 equations that are most likely incompatible. Maybe not, okay? But most likely, if you just got a random situation, they're incompatible, okay? I mean, it could be that this row is a multiple of this. That's the only way that you would be able to get anything resembling a solution here, okay? And what's another way of determining if a matrix is non-singular? Determinant's not 0. One of the big things about determinants is if the determinant of your matrix is 0, you can't invert it. Okay?